Okay, here's a question about a circle. We're given the centre and the radius of the circle, and the first thing we've got to do is write down an equation of the circle. Write down means it should be dead easy, and in fact if you look at the front of your booklet you should have on there the standard recipe for a squaredy bracket plus another squaredy bracket equals a certain thing. Plug in the right values using these numbers and claim 3 easy marks if you know your material. Part B, verify that the point P, there's P, lies on the circle. Verify just means check. It means we're allowed to assume these coordinates, and we've got an X and we've got a Y, and to verify those coordinates lie on the circle, all we've got to do is check that this equation that you've got is true at the point P. So if it works, then you've verified the point P lies on the circle. If it doesn't work, then maybe you made a mistake with your equation, so you can go back and change that. So substitute the coordinates in, check they work. Okay, then part C, find the gradient of the line CP. So I've got the point P62, there's C, and this is back to chapter 3, standard method, either draw a triangle or do 2 subtractions being consistent, and do the difference in y over the difference in x for the gradient. Then we've got to find a gradient of a line which is perpendicular to CP. Again, back to chapter 3. Look up in your notes what the condition is for being perpendicular if you've forgotten. And then we want an equation for the tangent to the circle at the point P. So, the tangent is a straight line, so we need 2 things for a straight line. We need a point and we need a gradient. Okay, the diagram may help. We need a point that is on the line we want, which could be that one, and a gradient of the line, so you need to remember, in order to get a tangent to the circle, how you get a gradient for that tangent, and it is in your notes for chapter 4. Look at the worked examples.